Question 5. You're given the diagram, this one here, y is equal to x squared. And you can see there's some shifting and moving going on the way they describe it in the question. Diagrams 2, 3, and 4 show sketches of y is equal to x squared after it has been moved parallel to the x-axis, the y-axis, or parallel to both. And you're asked to write the equations down. So good knowledge of quadratics here. So what's happening here? The graph has moved up 3. So it's going to be y is equal to x squared plus 3. This one has shifted to the right too. So you can see here, the solution, the root here would be x equals 2. So the factor there would be x minus 2 equals 0. And if you see that this is a double root type quadratic, double root, or a perfect square, double root, the graph of this one would be x minus 2 to be squared. And with this one, we can see it's the same graph. It's shifted the x minus 2 to be squared up 3. So this one is going to be x minus 2 to be squared plus 3. Now, what's the minimum point of this? 2, 3. Do you remember completing the square? Look familiar? So you could multiply that out. X squared, they don't ask for it in a particular form. Minus 4x plus 4 plus 3 equals 0. So x squared minus 4x plus 7 equals 0. And what else can we say about this graph here? It has no real solutions as it doesn't cross the x-axis. And that goes back to our discriminant in the previous question. Let's look at b squared minus 4ac here. We're going to get 16 minus 4 by 1 by 7. So my b squared minus 4ac is less than 0. You can see 16 minus 28 is less than 0. Therefore, no real roots. So you should have a good knowledge of quadratics at this point of your Leaving Cert careers. Part B in this question, you're told to sketch the graph with the equation y is equal to the absolute value, these modular bars, of 4x minus 3, stating the coordinates of any point where the graph cuts or meets the axis. Now, why are they saying meets the axis? Is that we don't go below the x-axis here with these modular equation graphs. So it's a sketch, so we don't have to draw it to scale, but in an exam you're going to use graph paper and you're going to draw these as much as possible to scale. So let's get a couple of points on this graph. We want where it meets the x-axis and cuts the y-axis. So let's get the y-axis first. If x is equal to 0, what's y equal to? So we would have y is equal to 4 times 0 minus 3, but it's the absolute value of it. So y is equal to the absolute value of minus 3, which is 3. So we're just sketching it. So I'll just say that this is 3. What about when y is equal to 0? Let's see what x is. If y is 0, 0 is equal to 4x minus 3. 4x equals 3. X equals 3 over 4. So 3 over 4. So let's just approximate it to be here. 3 over 4. And we're asked to sketch this graph. Let's get one more point to the right of 3 over 4. Let's just take if x is equal to 1. If x is equal to 1, 4 times 1 minus 3 is 1. So y is equal to 1. So approximately here with the point 1, 1. And it's obviously a mirror image going in the other way, the other direction. Part 2 of this question, find the complete set of values of x for which the absolute value of 4x minus 3 is greater than 2 minus 2x. We're going to use algebra now in a second to solve this, but let's have a look at if we imagine that y, this is a function on its own merit, y is equal to 2 minus 2x. Let's get a couple of points here. If x is 0, you can see y would be 2. And if y is 0, you can see that x would be 2x equals 2, so x will be 1. So if we plot those points 1, 0 and 0, 2 approximately, it looks like the values that I'm going to be getting, not much of a straight line, let me try that again. So our values look like they're around here, this one and this one here. For this blue graph, the absolute value of this to be greater than, it needs to be going in that direction. and up in this direction. So let's see, do my values. This is a 1, this is a 2. So let's see what we get if we multiply this out. Well, we're going to square both sides here. So squaring the left hand side, we're going to get 16x squared minus 12x twice and plus 9. And if we square the right hand side, we're going to get 2 by 2, which is 4. You should probably write it out like this: 2 minus 2x by 2 minus 2x if you need to. But you can see it's going to be 4 minus 4x twice minus 8x, and we're going to have plus 4x squared. And if we bring all of them to the left, we're going to have 16x squared minus 4x squared, 12x squared, minus 24x plus 8x, so minus 16x, and 9 minus 4 would be plus 5 and greater than 0. So factorizing this, well, it has to be 5 by 1. Has to be 5 by 1. 6x and 2x, does that work? It looks like it does. 6x and 2x is going to give me 6 and 10, 16, and they're both minuses. So my solutions for x, we'll let them equal. It's going to be 5 over 6 or 1 over 2. Now that does equate with our graph that we kind of approximated here. This one here is going to be the 5 over 6. And the one slightly less than 3/4 will be your 1 over 2. So you can say that x will have to be greater than 5 over 6 and x would have to be less than 1 over 2. You can write it like this.